In this video, we'll be solving systems of equations using the substitution method. So before we get started, what is a system? So a system is a set of two more equations with the same variables. For example, if we have these two equations here, notice that they both have the variables x and y. If I were to graph these two systems, I would say the solution to the system is going to be where the two lines intersect. And in this case here, it would be this point, which is going to be at -3, 2. And so what that means is the point -3, 2 is a point that not only solves the red equation, it also solves the blue equation as well. Sometimes we don't always want to make a graph to solve a system, so the substitution method is a way of solving the system algebraically, just using the numbers and letters. So let's go and see that in action. So here's our first example. I have y equals 5x and y equals 3x plus 6. Since we're looking at two equations, this is a system. And what the substitution method does is, if I know one thing is equivalent to another, I can switch out one for the other. So if I know that y equals 5x, every time I see the letter y, I can substitute it, I can replace it with 5x. The rest of my equation is going to stay the same. I still have 3x, and I still have plus 6. So let's go and solve this equation. So if I want to solve for x, I need to get x by itself. And it's kind of hard to get x by itself when it's on two different sides like this. So let's get rid of one of these x's. How can I get rid of 3x? Well, the opposite of adding 3x is to subtract 3x on both sides. 3x and minus 3x, these are going to cancel out, leaving me with just 6. And on the left-hand side, we have 5x minus 3x, which is going to be 2x. Okay? X is almost by itself. I need to get rid of that 2 in front. How do I do that? We know that the 2 is multiplying with x, so the opposite of multiplying is to divide. So 6 divided by 2, what's x going to be? X is going to be 3. Right? We're not quite done yet because we still need to solve for y, but knowing that x equals 3 now, we can use that to help figure out what y is. So to figure out what y is, I need to use one of my previous equations, and it doesn't really matter which one we use. Just to make things a little bit simple, I'm going to use the first one, y equals 5x. And now using my newfound knowledge that x equals 3, every time I see a little x, I can now switch it out with 3. And the rest of my equation is going to stay the same. I still have this y, and I still have this 5 in front. So y equals 5 times 3. So what's 5 times 3? And the y is going to be 15. So the solution to the system is going to be the point 3, 15. And that's going to be the point where the two lines intersect. All right, let's take a look at our second example. Here I have y equals 4x, and then 4x plus 2y equals 12. Again, how the substitution method works is, if I know that y is equal to 4x, every time I see the letter y in the other equation, I can switch that out with 4x. Now the rest of my equation stays the same. So I still have 4x in front, I still have this plus 2 in front, and on the right side I have equals 12. All I did was substitute y with 4x, because I know those are equal value. So now let's go ahead and solve for x. 2 times 4x, what's that going to be? If I double 4x, I'm going to get 8x. I still have this 4x in front, and I still have this 12 on the right side. Right? Now let's combine 4x and 8x. What's 4x plus 8x? 4 plus 8 is going to be 12. And since these are x's, 12x equals 12. X is almost by itself. I need to get rid of this 12 in front. How do I get rid of this 12 in front? I know that two numbers next to each other means to multiply. So the opposite of multiplying is to divide. So dividing both sides by 12, I know that x is going to be what? What's 12 divided by 12? Any number divided by itself is going to be 1. We're not quite done yet. Since I know x equals 1, I can now go back and figure out what y is. So just for this example, let's go and use the first equation, y equals 4x. And now knowing that x equals 1, I can do another substitution. Every time I see the letter x, I can now switch it out with 1. So when I see this letter x, I can now replace it, I can substitute it with 1. The rest of my equation stays the same. I still have y, and I still have 4. So what's 4 times 1? Y is going to be 4. Let's take a look at our last example. So at y equals 7x minus 7, and negative 4x plus y equals 2. So just like before, even though y is a little bit more complicated, if y is equal to 7x minus 7, whenever I see the letter y, I can replace it with that thing. So I'm going to replace y with 7x minus 7. The rest of my equation is still going to stay the same. still going to have this negative 4x in front. I'm still going to have this equal to 2 on the right side. All right, now I'm only dealing with x's. I can now solve for x. So what's negative 4x plus 7x? Let's combine like terms. 7x take away 4x, that's going to be 3x. I still have this minus 7, and I still have this equal to 2. How do I get rid of this minus 7? The opposite of subtraction is to the dad, so I'm going to add 7 on both sides. Leave me with 3x over here. And what's 2 plus 7? 9. Okay. And then finally, how do I get rid of this 3 in front? I know that 3 is multiplying with x, so the opposite of multiplying is to divide. So I know that what's 9 divided by 3? X is going to be 3. Now knowing that x equals 3, I can use substitution one more time to figure out what y is. So using my previous equation, I know y equals 7x minus 7. Since x equals 3, every time I see the letter x, I can substitute it, I can switch it out with 3. The rest of my equation still stays the same. I still have this 7 in front, I have this minus 7 in the back. All right, and now let's solve for y. What's 7 times 3? 7 times 3 is going to be 21 minus 7. And what's 21 minus 7? Y is going to be 14. So I know that the point 3 comma 14 is going to be a solution to this system. So in conclusion, what the substitution method is, if I know that y is equal to something, every time I see the letter y, I can switch it out with whatever it's equivalent to.